I'm gonna go over some of these evens. I'm gonna guess you guys got the picture right. So he walks east an hour and north an hour and a half. Call it 1.5. And then the question is, what course should the hunter take to return to his starting point? So we're going from here back. Like what angle should he take? So remember that due north is like 0 degrees. So how far from north going clockwise is it? This part from here to here is going to be 180. And so we just need to do 180 plus this angle of the triangle. What kind of triangle is this? 90 degrees. It's a right triangle. So if it's right triangle, we don't have to use law of sines. We can just use SOHCAHTOA. So relative to this angle, we have the opposite and the hypotenuse, and the adjacent. So which trig function uses opposite and adjacent? Tangent of x equals opposite over adjacent. Alright, can you guys take it from there? I'll pause while you meditate. Don't forget to do 180 degrees plus angle x.
So you said the answer plus 180?
Yes.
Wait, do we just, is the angle the answer? Number 8?
Yeah, it said what course, like what heading, that would be an angle answer. I don't think it asked how far you had to walk. No, it did not. You can figure out how far you had to walk using Pythagorean theorem. That's probably why they didn't ask. But, okay, that's it. Number, what was the next one? 12? No.
Yeah.
Is it 12?
Yeah.
Yeah.
Did you just punch her in the throat?
Yes! She literally lies back and she goes,
She took a rubber band and she
after she threw it at my head. What? You threw the rubber band at my head.
All right, number 12. A sailboat leaves its dock and proceeds east for 2 miles. All right. So far, so good? Everyone on the same page here. It then changes course to 205 degrees. Okay, where is 205 degrees? Yeah, where's 180 at? Maybe I should ask that.
What?
180 is straight down. This is 180 right here. A lot of times drawing north-south lines help. So, 200, was it 205?
Yeah.
205 would be a little bit past that. How far past 180 is 205? 25 degrees. I'll put a little 25 in there. That'll probably help later. How far did we go? Until it's due south of the dock. Oh my gosh. Yeah. Let me shorten this line up so it looks... Okay, dock is where they started. So like right here. So, due south. So, directly east, directly south. That'd make a 90-degree angle too. Okay, what are we asking? How far south is it? How far south of the dock, I guess. So, X.
270 minus 2.
So, do you guys know how I got this 25 right here? This 205 degrees is 25 degrees past 180, well, 25 degrees past south. So what would this angle right
65.
here be? How'd you get 65?
270 minus 205.
Wait, what?
270 is directly
minus
east, so you take out.
Oh. Okay, I was just thinking 90 minus 25. I see what you're saying now. But yeah, that's good too. 270 minus, 205. Yeah, that's why I wrote that 25 in there, because this is the right angle, so yeah. Anyways, either way it's good. Okay, so again, we got a right triangle, so you can use SOHCAHTOA. I think I might stop there actually. You guys can do it. It says how far south did they end up from the port? I kind of forgot what we're talking about. From dock. So we're looking for X. This is the angle. You guys remember SOHCAHTOA, right?
Yeah.
Adjacent, opposite, adjacent.
So, what if we already did that one?
Oh, I thought you said 12.
No, it was 10.
Oh, you got it right. That's why you knew the angle, because you'd already done this. Okay, number 10. Point S is 4 kilometers west of point R. So it was 8, 10, and 14? Okay. I think 14 might be a challenge. I have vague memories about that one. Okay. Number 10. Point S is 4 kilometers west of point R. Okay, there's west. Point S, point R, 4 kilometers. So far, are we agreeing?
Yeah.
Okay, point T is southwest of S. Wait, did it say how far? Point T is 4 kilometers, another 4. Okay, you guys know what this angle right here is going to be.
Would it be 180 plus 45?
Yeah. Well, that would be this, but I'm more interested in
Be
this
120.
angle. Okay, so I drew a north-south line right there. What's this angle right here on this side? 90. How about this one? Okay, it's 45. How do I know that? Because southwest splits right down the middle between south and west, right? So it's splitting this 90-degree angle in half. So that's 45 if I drew it right. So this angle right here is 90 plus 45.
Yeah.
So I'm guessing you did not get that angle, or did you?
I didn't.
Yeah,
I didn't. That's the
yes.
problem. I didn't know how to get it.
Did that make sense though?
Uh-huh.
And I'm guessing, are they asking how far is T from R? What are they asking?
Yeah.
Are they asking 2 questions? Find the bearing and distance of R from T. Okay. Actually, alright, this is still a little bit tricky though. So we're looking, they mean we're looking from T towards R, not R towards T. Because the way they said it, it says the bearing and distance of R from T. So we're looking from T back to where we started. So we need this bearing. Hey, draw the north-south line there. So we need like this angle. That's going to be the bearing.
Couldn't we just do law, like cosines?
And we need this distance.
And then couldn't you just do like the second version to find the angle of R and T since they're the same? Since they're both 4 kilometers.
Yeah, we can cheat a little bit and use isosceles triangle. Well, the side angle side is law of cosines. That would be used for this. Also, you can use side angle side to find the area of the triangle, which we don't need. But yeah, law of cosines would help us find x. But because I can find these 2 angles without, I can use law of sines too. You guys know how I can find these 2 angles?
They're equal.
Oh, so yeah, there's the same.
Yeah, because it's an isosceles triangle, 4 and 4, the base angles are equal. So 180 minus 135 is 45. 45 split into 2 is 22.5. So since we have more angles, you can use law of cosines to find x. Okay, I kind of need to know the bearing. I need, I guess I'll call this a y. I need y and 22.5 to find this bearing. How am I going to do that? I'm going to make my north-south line. So I kind of just start drawing in north-south lines and east-west lines wherever I feel like I might need them. Do you guys know what this angle right here is? Remember this was,
80 minus.
remember, yeah, it was 45 because remember it's like split in southwest, so it's like directly. And that's 90, 45, 45, 90. So the bearing, the heading, like what direction they're going, is that plus that. Yeah, this was a tough one. Yeah, that one was a tough one, I thought. This one, you guys probably, a lot of you got already, I'm guessing.
60,
Don't.
So for x, you could do, for example, sine of 22.5 over 4 equals sine of 135 over x.
Why did you give the other answer? Because nobody's doing it.
No, I'm not.
I'm 100%
You're trying to
confident I
find
got
X.
most of these questions.
Oh, so the side of the side.
Except the ones that you'll just.
That's not what I would do.
Isn't it? To get the X, it's side of the side.
Can you just do circle to it?
The law of
You're not listening the past 2 minutes. Okay, I said yes.
Yeah.
Because you have side angle side, you could use law of cosines, like c squared equals a squared plus b.
Uh-huh.
But because we know these angles, we have enough to use law of sines. Sine of this over 4 equals sine of this over.
Oh. I knew that.
You zoned out when you thought I was going to do the whole problem.
Shut up, Paul.
This is number 10. Okay. 14, you said, right? I'll start drawing. Drawing. A ship leaves port and sails northwest for an hour. Alright, does it say how fast they're going? No. 1 hour. Then northeast for 2 hours. It should start lower. Should have made this line simple. It does not change speed. Find the course the ship should take to return to port. I remember this problem. Up there.
Well, what is
Can I draw that line straighter? That's close enough. the picture looks something like this. I guess I'll draw another north-south line, just kind of at all the important points. I think that might be helpful. So, this is directly northwest. So this is a north-south line right here that I threw in there. So what would this angle be right there? 45. Yeah, this is a tough one. Alright, do you guys know what this angle is going to be? It's 90. So you're going northwest and then northeast. And that's, like, here's the 4 directions on a compass, right? So northwest and northeast, now if I drew it right, are also, just like north and east are 90 degrees apart, northwest and northeast are 90 degrees apart. Anyway, so like if I drew this would be 45, this would be 45. So anyway, it's 90 right there. This might be one of those things where there's more than one way to do it. Did it just ask for the heading? Oh, and how long it will take. So we need the heading. I'll call this X, like the direction you have to go to get back. And I'll call the time is the same thing as the length because they said we're going the same speed. So anyways, Y is kind of like the length of that. But the length is at time. Okay, here's my plan. So I drew 2 north-south lines right here. What do I know about this little angle right here? It is going to be identical to this angle right here. How did I know that?
Because of the thing we did a few years ago.
Yeah, because of geometry. These are called alternate interior angles. If the lines are parallel, alternate interior angles are congruent. So my north-south lines are parallel, and these are alternate interior angles. They're the same. They don't just look the same, they are the same. So if I can find this angle, or this angle, I can do 180 degrees plus that angle, and that will give me the bearing. That's the harder part. Well, how can I find this angle? Right there. Well, we could use, since it's a right triangle, we could use SOHCAHTOA to help me find like the larger angle, like from here to here. And do that minus 45, and that would give me this angle. So, relative to this angle, I'm kind of running out of letters. I'll call it the big angle, angle Z or something. Right there. I have the adjacent and the opposite. Opposite over adjacent is tangent. Tangent of angle Z is opposite over adjacent. So to find Z, we need to do tangent inverse of 2. Toughy, wasn't it? Anybody think they got it on their own without?
Yeah.
Caden thinks he might.
Get out.
What?
63.4.
Okay. Now, that would be this entire angle from here to here. And we want just this little part, so I'm going to subtract 45 from that. Did you do it this way or did you do it another way?
I did log cosines first.
Oh, you did log. Okay. What would that be? 18? Okay, if this is 18.4, this is 18.4. And angle X would be 180 plus 18.4, so 198.4. It just says what direction, what course. They use the word course. What course should they take? 198.4 degree course.
1 squared plus 2 squared equals 5 squared.
Yeah, we can, I hope got the easy way to do this one.
Uh-huh.
So, since it's a right triangle, we can use Pythagorean theorem. We don't have to use law of sines or whatever. So 1 squared plus 2 squared equals y squared.
2.24.
Yeah, square root of 5, it's kind of a mess. 2.24 hours. I wonder if they changed it to minutes. No, they did not. Alright, I ended up doing all that, didn't I?
Yeah, what a hero.
Can you
I
do
was
it?
suffering last night.
You did it,
That's why I helped you, because I knew you tried.
I got the angle. I just didn't know that it didn't occur to me.
Well, there's always like, the more complex the problem, the more that's like there's 3 or 4 more ways that there are to do it. So that was just what I thought of first. It might be the easiest way, it might not.
All I can taste right now is like,
All right, you guys ready to grade?
Yeah.
strange